This meeting is being recorded.
All good?
Okay. Uh, okay. Hey everyone. So just like we talked, right? So we'll be talking about controllers today in this meetup. Like we said, I've been working in this area for a while now, and I guess I do have some ideas. But the content of this is mostly going to be community sourced. I tried not to bring in new contents here because what we have in the Kubernetes community has been tried and tested out and contributed by many people. So whatever we talk about is everything is there in the Kubernetes community, and I'll probably share those links with you later on so you can follow up afterwards. I wanted this session to be, more interactive and not just me talking. And at the end of the hour, no one knows what really happened. So we'll probably do that. There's not a lot of slides, so if I just read through it, I'll probably get over in the next 5 minutes. So let's try to make it more interactive. I might not have every answers to all the questions that you have, but we'll try to figure that out. And it's a journey. So we'll take it from there. So just to start with, using a show of hands in the chat, can we know like what kind of experiences do people have with controllers and Kubernetes in general, so that I can stay at that level of details?
Yeah, you can just unmute and speak about your experience if anyone is interested.
Hey, so this Rujin, I've just moved into the Kubernetes world. We support a bank domain. Basically, I'm working on Tanzu Kubernetes, like TKGI. So I've just started, and I'm looking forward to learn or gain some knowledge on this via this session. So yeah.
So, Richard, did you say you are using Tanzu? Did I hear
Yes.
that? Like, how big is your cluster? As you said, you are
Okay.
using Tanzu. Yeah.
Okay. So it's a small environment. Okay. So we have so we're just migrating from Cloud Foundry to Tanzu Kubernetes. So as of now, it's a very small environment. We have already minimal applications running on them. It is like we have right, VMware uses their own products like for deploying, so they don't use the cluster APIs. They use something called Bosch for provisioning the nodes and all. So it's a small environment. It is as of now. It is like you have 12 worker nodes and you have kind of 3 master nodes set up. So that's a small environment I'm currently working on.
Okay, great. Maybe Umanga got some other questions as a follow-up to the session.
No, it looks like most of us have some experience or have been in touch with controllers and the platform, so that's good. I guess in Red Hat, we use OpenShift, which is also a version of Kubernetes. And, where I'm going with this is in OpenShift, basically everything is controllers and operators for us. So if you had experience with that, you basically see everything that we do is operator-based or controller-based these days. That also gives us, ability to manage larger scales of things without almost with zero touch. That's what we strive to get in everything we do. So yeah, we'll touch upon what operators are eventually, but yeah, let's get started with controllers for now. So Kubernetes controllers, right? So this is the building block of automation that we have in Kubernetes. So even Kubernetes extensively uses controllers, and then the community uses controllers to extend on top of what Kubernetes provides. And the whole ecosystem around controllers and APIs are really well built. So yeah. So what's controllers, right? So Kubernetes documentation defines controller as an infinitely running routine. So in a general developer term, we could just say it's an infinite loop that does something. So it's just a for loop that will continuously do something that it needs to do. So what controllers are generally, doing is they need to watch for a desired state. So in any system, right? So there is a desired state that the user wants to reach. So controllers are responsible for taking you there. So they continuously watch for what the users want. They also watch the current state of the system, what is there, and they continuously work to take the system from current state to the desired state. So we'll look into what desired state and current state is and how we define those. But yeah, let's start with, so currently it's a that controllers watch for current state, they calculate the difference that is required to go to the desired state, and it reconciles that. So for example, with deployment controllers, which is pretty popular in Kubernetes, so whenever you create a deployment resource, you say that, okay, I want this Nginx pod to be deployed, or I want this MySQL pod to be deployed. The deployment controller makes sure that the pod is deployed based on the desire, the spec of the deployment that you provide. So that's controllers in very layman's terms. So if you look at code, this is basically a controller, right? And everything else that is there is an implementation detail inside it. So an infinite for loop that has a desired state that gets a current state of the system, it makes changes to take you from current state to desired state is what controllers are. Okay, so yeah, few things that makes controller the way it is today, right? So there's this thing called label triggers, which is what controller implementations are based on. Most of the things that we do in Kubernetes, I guess, label triggered, the automations. So what it means that, right? So when we do controllers to reconcile state, we do not care about, or we do not make assumptions about the change of states. What we care about it, what is the current state of the system and where it needs to go from there. So if you see some kind of a Boolean flag that has a value of true, you cannot assume that the value changed from false to true, or it was true and then it's still true, right? So you just know that it's true at this point of time. You don't know what was the history behind it or what's going to be the next for it. So that is where label trigger comes in. So the state of the system at which you are is what matters, and that's what we take. And to that extent, right, whenever we're implementing controllers, we don't provide it any state information, the existing state information. So every new reconcile basically tries to read through the state of the system and then make a decision based off of that. So yeah, label trigger is a design choice that we made, and it really helps with the controller's implementation. Then next thing we have is eventual consistency. I think if you, a lot of things, I mean, if you've looked into other talks or if you looked into implementing some of these things, eventual consistency is the word that keeps coming up here, right? So what does it mean? So if you do not make any changes to the system, right, so it will eventually converge. This is what Kubernetes is about. So if you say, I want a deployment of any pod with 5 replicas, you'll eventually get it. But if you continuously make changes to the desired state of the system, it will probably take some time to get there, but you will get there. There's no guarantee that it will happen immediately, but it will immediately happen. It will happen eventually. So that's what eventual consistency is about. So when we do controllers, right, and when we are looking at getting from current state to the desired state, it might be a case that controllers cannot work for some time. Garbage collection is happening, so your process needs to wait for it to happen. There's some other higher priority task that comes in, so you need to wait. So there's no guarantee that the controller will immediately take you from your current state to the desired state. So, but eventually it will be consistent and you will get to the state where you want. So that's what eventual consistency is about. And if you think this and take a link it with the label trigger concept, right? So you cannot really rely on seeing the state changes and then making your controller decisions based of it, right? Because you might probably miss it. So if your controller is waiting for some other events, some other controllers to complete a task, you might miss the state change events. So instead of looking at the state change, looking at the current state of the system is what helps controller become more better at what it does. So yes, these two are the like very good concepts that are used and makes controller very nice to work with. So Kube Controller Manager, so we've seen everything in the Kubernetes community, Kubernetes ecosystem itself is controllers, and Kube Controller Manager is the biggest example for that. So if you look at deployments, it's managed by deployments controller. There is pod controller for pods. There's service controller for services. So each thing you interact with in Kubernetes is about controllers. So there is an API that they use to define the state of the system, like what do you want, and then there's controllers for those that make sure that the state is reached. These controllers are bundled with Kubernetes and deployed when you deploy a Kubernetes cluster. So we'll look into it a little bit further in the session, I guess. Okay, so let me try to bring up a cluster and I'll show you how this works. So like I said, Kube Controller Manager is the component that has all the controllers that makes the Kubernetes resources function, right? So how is it actually deployed? So you cannot deploy it as a deployment because this controller is itself the component that's supposed to be handling deployment. So how does the first controller come into picture, right? So how is Kube Controller Manager deployed? So let's look into it. So here I have this kind cluster. Just to confirm, Humble, you can see the screen, right, with my terminal?
Yeah, I can see your screen. And in between, there was a question: is there a way to list all the controllers in a cluster?
List all the controllers. It might not be possible to do that. I don't
Right.
because it's not backed by any kind of a resource.
Right.
You put, yeah.
Yeah, one way I was looking into the code of controller manager. Actually, you can see maybe bunch of controllers over there defined in the start initialization function, and that's where you get some idea. But if you look at the code, there is easy way to figure it out from the hierarchy. But I don't think there is a command as Umanga was mentioning because it's based on resources and things like that.
Yeah, pretty much. So in Kube Controller Manager, so the pattern that they follow is there is a manager and then there is a bunch of controllers managed by that manager. So if you look into the manager code for any of this controller code base, you see what are the controllers available and how they are managed there. But when it goes deployed into the cluster, it's basically one image that had everything running inside, and it runs as a concurrent Go routine. So you probably not see it there, right? And there's no easy command to say what controllers are there. We can always look at what resources are there, right? And you can make an assumption that every resource is probably backed by a controller at least. So that's might not always be the case again, but yeah, that's usually the assumption we make. So this is a kind cluster that I have created, and here I am inside the node. So let's just. So this is the default, very newly created Kubernetes cluster, and these are what is there in that, right? So there is a kube system namespace that we have. So let's just look into what we have in that namespace, and we'll go from there. So these are all the pods that comes with the fresh Kubernetes deployment. There is one for HCD. We know it's the database that we use. There's something for the API server. There's this Kube controller manager, which is what we are more interested in. And there's scheduler and there's proxy. So these are the things that are deployed when the Kubernetes cluster is deployed, right? But here's an interesting about this resources. It's not a deployment. So we saw a lot of pods for API server HCD, but none of those are backed by a deployment. Only core DNS is something that comes, that's a deployment. Maybe it's something else, right? So let's look at it. So it's not even a daemon set. It's not even a replica set, probably. See. So it's not any of the resources that we are aware of to deploy a workload in Kubernetes, right? So how is controller manager deployed here? So this is where this static pod kind of interaction comes into play. So if I go into the node, I cd into, and this works for any cluster that is deployed using kubeadm. So if you go into HC Kubernetes manifest, yes, Amber.
Sorry. Yeah, go ahead. started.
So yeah, if you get into the master nodes in any of the Kubernetes deployment and you look into its Kubernetes manifest, you'll see these files, right? So the HCD, Kube API server, controller manager, and scheduler that we saw in the Kube system namespace. So these files are defined here. It's not in the API server. So even in case of API server failure, right? If your HCD goes down or your API server pods are not running, Kube controller manager process should still be running. It might not be able to do anything useful, but it will still be there. And let's look at the content, right? So this is very similar to how we define deployments and pods and everything, but it comes from outside. So this is a pod, and this is how static pods work. It's directly deployed by kubelet onto one node. So it's there when you start your Kubernetes cluster. So it's still an API version v1 and kind of pod, but it's not a deployment, and it's handled by the kubelet directly. And so if I actually delete this resource, you'll see that the pod actually goes down and it never comes up until I recreate this resource, which is kind of a destructive way of testing things out, but let's not do that for now. But what we can try for fun is, so this is just a pod, right? It's not a deployment. So maybe if I delete it, it won't come back. So let's just see if that happens, right? I just deleted it, but it's comes back automatically. It's pending and it's coming back up. So yeah, this is the interesting part where, all the other things are managed by controllers, but this controller itself is again managed by something else, right? It's the kubelet process that's running that deploys this. So yeah, so kube controller managers are really unique in that sense in controllers world. And yeah, that's pretty much what I had to show for this. We'll probably get back to more of it later on as far as the demo goes, right? So let's look into custom controllers next. Custom controllers. So we talked about kube controllers, right? But it might not always be useful for the scenarios that we have. So every business has a different use case for the controllers. They probably want to do different things. Just creating deployments, just creating services is not enough, right? So for the MySQL community, deploying MySQL in Kubernetes was probably a challenge at the beginning, and then they had to write a MySQL controller to do it. For Kafka community, deploying Kafka and the Kubernetes cluster and not worrying about individually or manually setting things up. So they wrote up Kafka controllers, and secret sync controller is one of the interesting pieces that is there. So you might want to sync your secrets between different namespaces without anyone else knowing about it and not having to do it manually. So all these kinds of custom use cases are there. And these are more generic use cases of controllers. So you can probably use the already available resources with some of your resources of your own, and it doesn't require any specific domain knowledge included in it. So this is where custom controllers come in. So you probably just want to reduce manual labor to automate something. You write a controller for it. And controllers can work with any kinds of resources, like I said. So you could work with the existing Kubernetes API resources, or you can build your own custom resources and make your controllers react to it. Let's look at the structure of controllers next, right? So controllers are written in different ways. Since the starting, there was one kind of a framework structure that we used, but then community started building lots of toolings on top of it. There's Kube Builder, there's Operator SDK, there's Kudo, and there's so many other frameworks that came in that built on top of it and added their own optimizations, right? So now you see lots of different kinds of controllers implementation, and the actual raw controllers implementation actually gets lost when you use these tools because it's basically designed to hide those kind of details, right? So what we're going to do is we're going to take a step back and go back into the older days of controllers and look at how the first set of controllers were written. So we open this up. So this is an example that I've taken from the Kubernetes sample controller repository. I have added a link to the end of my slide, but Yeah, this is how a raw form of Kubernetes controller looks like without using any kinds of external tools to generate this kind of thing. So uh, in object-oriented world, this would probably be a class, but because this is Go and we use structs and type definitions to do a lot of things, we define a controller object as such, right? And so controllers, when we talked in the beginning, it needs to watch for the desired state. It needs to get what the current state is, and then needs to do all the work that needs to be done, right? So that's usually the work of controllers in Kubernetes. So the clients in Kubernetes. So you usually need clients that can talk to deployments, stateful sets, all the resources. If you have custom resources, you need clients to talk to that and to watch those resources, right? So generally, you see a controller having a Kubernetes client interface and then the client set for your custom resources if you have any. So this is very common. This particular example, creates a deployment based on a custom resource and orchestrates that. So in this example, you see there is a deployment lister, which basically allows you to watch a deployment in Kubernetes and get a list of all the deployments. There's something called as an informer sync, which basically means that make sure your cache is updated with all the resources that you want to before you start orchestrating it. Otherwise, you might be working with a stale cache, so you don't really know what the state of the system is, and you might make a mistake that would lead to your cluster breaking or data losses and all that. So there is another resource called foo, which is an example custom resource. So there is a lister and informer for that. What's interesting and what drives the controllers is this work queue part here. So every work that the controller needs to do is usually added into a queue, which is rate limited. So whenever you watch for an event, right? So there is an event change, it gets added into this work queue and controller will eventually get to it. So this is where eventual consistency comes in. So you see the state, it's not immediately going to work on it. So it will eventually get there and it will we'll see how this work queue thing works in a bit. So there's event recorders, which is very helpful if you want to record what's happening in your controller. So if you've looked into deployments, if you do a kubectl describe of deployment, it gives you a list of events that happened that took you from no deployment to replica 1 or replica 2 deployments of the resources that you have. So this is how a controller is generally structured. And these are the building blocks that we build on. This new controller is just a helper function that helps you with initializing all the resources. What's interesting here is this event handler part. So this is what triggers your controllers to do some work. This is what adds something to the queue. So if you, for this example, right? So there is a foo resource in the cluster and you're watching for it. So whenever there is an event that occurs, you basically relate it to a handler that says, okay, whenever you see that a new resource called foo is created, you add it to the queue. When you see that it is updated, you compare your old foo versus the new foo resources. And if it is something that I'm interested in, you again add it to the queue so that my controller can work on it. So that is what informers are for. This is what powers the whole controller, right? And there's other event handlers for deployment. So we'll see this in action. So what this example particularly does is when you create a custom resource, you give it a name of a deployment and how many replicas do you want. So this controller is going to go ahead and create a deployment with that name and number of replicas for you. If someone manually deletes a deployment, it will recognize that and it will recreate the deployment because you basically said that, okay, I want this deployment to be there. So it will make sure that it is always there.
So Umanga, just to disturb in between, there is a question in the chat, I believe. Got notification at least.
Yes. So what's the difference between client-side interface and Kubernetes interface? Yes. So Kubernetes interface is what we use when we're talking to all the Kubernetes resources, right? So that are generally imported as Kubernetes.interface. This interface basically has all the other interface required to react with Kubernetes. Client-side interfaces are usually there's a Go tooling that generates clients for all your custom resources, and in that, all the interfaces are backed by your client set. So it's just, I guess, a kind of naming convention. So client sets are usually related to your custom resources, and Kubernetes.interface is what is the for the default resources. So yeah, any one naming is enough. I guess it's how you choose to import those and make use of it, but the details of the interface is more or less the same. So hope that answers that. Right. So what earlier we said, right? It's an infinite learning loop. So this is where it all starts. So you run, there is a run function. There is a number of workers that you want. So if you want 5 different, workers running and handling your work concurrently, you could do that. This is where all the controllers start. So this is an infinitely running Go routine. Like it starts starts a Go routine. It starts all your caches so that it can be synced, and then it starts all the workers, and yeah, the worker is where all the fun begins. So this is boilerplate code to start your controllers from to run. So if you look at this is controller basically. There is an infinite loop that processes your work item. So if you remember the second slide that I showed, it was an infinite for loop that got your current state and took you to a desired state. So this is an infinite for loop that does that. So this is in essence the controller at its core, right? And if you look into the implementation of process, this next work item, it basically the work queue that we talked about in the beginning. You get a work item from that queue, you process the work and you mark it as done, and you're basically done with that work, and then you move on to the next one. So you infinitely look through the queue, you get what work needs to be done, and you do it. If there's no work, you just stay idle, and eventually every 1 minute or every 10 minutes, based on how you configure it, you keep checking the queue for new work to be done, and you do it. So that is in essence how a controller works. So everything else that you see is an optimization, an abstraction, and use case based of things that are done here. So the sync handler part is the logic that handles what needs to be done. So like I said, in this example, we read a foo resource and we create a deployment based on the specs of that resource. We'll look into the specs later on, but this is the actual job that gets done. And it's not much thing. There's nothing much of interest in this. And that's pretty much it in the controller structure. Now, what's next? So custom resource definition. Now I've talked about this foo resource for a while, right? And how do we define it? What is foo resource exactly? How does Kubernetes enable it, right? Okay, there is a question in chat. Let me look at it first.
No, I was just mentioning about the desired state to map with input. Yeah.
Okay, so we're just getting to that. So custom resource definition is a Kubernetes API resource that allows you to extend the Kubernetes API server. This is the beauty of Kubernetes in some way. I really love this part of how this works. So you define a YAML file that gives you this, you define a spec of what you want for your controller to do its work. That's your custom resource. You put it into a custom resource definition, and the Kubernetes API server handles managing it for you. So you don't have to write your own API server to handle all of this. You just define this is a kind of rough schema that I want the API server to have, and the Kubernetes API server will make it happen. So that is what custom resource definitions are for. And usually custom resource definition, if you go back to the object-oriented model, it's kind of like a class, right? And there are custom resources object that you can create, which are like the objects of that class. And each of these objects can define different states of the system. So the foo resource I was talking about, there is a custom resource definition that defines foo. And then there are multiple custom resources that can define the desired state of foo you want. So there can be many at one point. And then every CRD, every custom resource definition is backed by a single controller.
Why do we need CRD or CR in a cluster?
Sorry, didn't get your question.
No, why we need CRD? I mean, custom resource definitions or CR in a cluster?
It's to extend the system, right? So Kubernetes comes with a default set of resources, and the only other way to extend it to for your use cases, right? So not everything that we can do can be handled by using deployments and pods and all those generic resources that is there. So you might want to extend the Kubernetes API and do some extra work, add your system, add domain specific things in there, right? So that is what custom resource definitions enable. Without this, you'd probably have to write your own API server and make sure your controller talks to it, handle all the authentication and everything else, right? And then you separately have to talk to the Kubernetes API server. So custom resource definition basically eases that for you if this is something that you need, right? But there might be cases when custom resource definitions are not enough. It's not an answer to your problem. So there are other API server creating resources that you can hook up with the Kubernetes API server and work with. So if we look into a MySQL kind of an example, MySQL probably has a MySQL custom resource defined. It defines the state of your MySQL database that you want. So what kind of how many replicas, where do you want your databases to be placed? Do you want backups enabled for those and all those kinds of information, right? That you would manually ask if you were manually deploying it in your servers, in your database, wherever, right? So custom resource definition is basically just that for housekeeping stuff. So example of custom resource definition, right? So enough talk on that. Let's look. So this is a custom resource definition YAML. So everything is in Kubernetes YAML, which is fun. So custom resource definition is default native Kubernetes API. So it is API extensions P1 is what provides this. So there is the spec of this is what defines a custom resource. So you're basically saying I want to define a new API group that is sample controllers.kts.io. And there are that can be different versions of your resources based on maybe the spec changes eventually in the next release, and you might want different set of information. So there is this version management that is added in there. You could serve different versions of your CRDs, but store one and do all sorts of conversion. There's schema validation where you could say, okay, replicas is just a number. It cannot be any text or any other pattern matching or anything. It has to be a number. So all those kinds of open API validations can be done. Right. So for this particular example, so like I said, the foo resource takes a deployment name, which is of type string, and it takes a replica, which is of type integer. And the integer value can only be between 1 to 10. So this is something the Kubernetes then handles for you based on this. So all this is implemented for you. Users had to write these 5 lines of YAMLs that said, I want this to be the state definition of my system, and it does for you. And then there is also the scope namespace. So if you've seen, resources in Kubernetes are namespaced or cluster scoped, right? So storage classes, persistent volume are all cluster scoped, and pods and PVCs are namespace scoped. And so you usually see yourself making decision between whether you want your resources to be accessible throughout across the namespaces at the cluster level, or you want it limited to a cluster. So the scope is where this is defined. Now, this YAML could get really big based on your API specs of what you want, right? And it could go to thousands of lines. So we usually don't write this by hand. So there's something else that does it for us, right? So in the resource code, you'll probably, in any of the controller code bases, you'll probably see a package API and the types.go file, which is what we use to define our custom resource using Go structs. And then you use the Kubernetes client generator toolings, all the toolings to generate these resources for us. So this is auto-generated from this types.go file. And this again is what the controller uses. Controllers cannot read directly from your CRDs, right? You need some kind of a struct so that you can, marshalling, unmarshalling, and all that needs to be done. So this is what we use for it. So you define a types.go file for the state of the system that you want. You add all this definitions, it's just simple Go structs that you do, and then you run a generator command that runs the generates the CRD for you. Example of a custom resource that is based on that CRD. So API version is what we defined in the API group here. Sample controller KTSIO v1 alpha 1 is what we use here, right? And it's of kind foo. You give it an example, and like we saw in the spec, it takes a deployment name and a replica. So this is a custom resource that is built off that CRD. Okay. There's lots of theoretical thing, and we'll get into the demo in a bit, which is the important part. So Kubernetes operators, guess everyone who's heard about controllers has also heard about operators, right? And the difference between them is really not clear. So what does operators mean, right? So if you think of controller as an implementation, operator is a design pattern that defines, how you use your control. So in operator pattern, you use your controllers and you use custom resource definition to build application specific knowledge to your program. So that's what operators are for. When you write controllers, they usually don't bring application specific knowledges to your system. So like deployment controller, right? There's nothing specific about deployment. So it handles all the deployments in a generic way. But when you need to handle an MySQL cluster or a Kafka base, right, or a Redis database, all those things, you need domain specific knowledge for those applications to be managed. You cannot just generally say that, okay, throw this into a pod and deploy it wherever it needs to be deployed. That won't work, right? So for things that need very domain specific knowledge to be managed, things that probably an admin somewhere is usually manually doing using imperative commands like deploy this resource here, make it into this many replicas, copy it there. All those things are codified into this operator pattern. So that's the only difference between controllers and operators. So controllers are used to build operators, so controllers can also be used separately. So when you combine controllers with CRDs to do anything application specific, that is what operators is about. So it provides automation for common repetitive tasks. So generally, people now have started saying that, okay, all operators are controllers. So whenever you're talking about controllers, you probably generalize it as an operator, but that might not always be true. So you might be able to get away with writing controllers sometimes, and you might need to write operators at the other time. So understanding the difference and choosing what's right for you is usually very helpful, because it saves you a lot of this extra overhead that comes with operators and domain specific things. So operators, they do specific things is where operators sign. So if you have to do things like creating backups and restore from it, provide disaster recovery for your application, all those kinds of things that are very specific to how your solutions, what your solution or what your product is, those things are usually codified into operators. Right, so these are the references that I have. So the sample controller is what we'll look into right now and how we'll try to play around with it. There is a good Kubernetes documentation on writing controllers, and then there is a CNCF operator white paper, which is what the CNCF community has built to, help us understand what operators are for and how it's different from controllers and so on. And I actually had the opportunity to review and contribute to this. So it's a really nice paper. Everyone should read it. Right. So now let's go back to the demo. The slides are pretty much done. So let's pull something up and start working. So I have. Yeah.
Just put a pause and ask for any questions on the line, if at all. Any clarity you required, anyone? Or maybe you have some questions to ask. Please feel free to ask. You can unmute yourself and ask.
Amal, can I go ahead?
Yeah, go ahead.
Yeah. What I was asking is that controller manager is managed by kubelet, and what if kubelet crashes? So the controller manager will go down. So do we need to start that again, or it will be means starting up on its own?
Okay, so kubelet manages the controller manager. What happens when the kubelet goes down, right? So the manifests are still there. As long as it's still there, we expect that kubelet will eventually come back up. And when it comes back up, it reads the manifest and starts managing the controller manager, right? And it will have to deploy if it is not already deployed. And if it is already deployed, it just takes it from there. But if your kubelet never comes up, then there is no manager process that manages it. So you could basically consider that node as down for now, right? It's the control, at least that replica of the controller manager is lost. So you probably depend on the other replicas to be functioning, because usually you probably have 3 replicas running, right? So even if one kubelet goes down, the other 2 nodes will help you cover up for that. So this is, yeah, that's basically the assumption we make. And if the kubelet never comes up, the controller manager is lost for good.
So essentially, it means on a high level, what kubelet is doing is that kubelet is reading every file in HC Kubernetes, and then it is making sure that whatever resources we define there, it is running on the node.
Yes, so yeah, that's how the static pod concept works. So kubelet, there is a directory that you pass when you start kubelet, basically saying, okay, if there is any manifest here for a pod definition, you deploy it on the cluster, right? And you are supposed to manage it. So that's how this works. So you could even write your own custom pods, maybe run Nginx just like kubelet controller works. Yeah.
Thanks, I got it.
Any other questions before we move on? Looks now good, Umanga.
Okay, so for this demo, we're going to use a sample controller that's provided by the Kubernetes community. So if you look at GitHub Kubernetes sample controller, this is maintained, and it directly comes from the Kubernetes active maintenance branch. So this is a latest on what controllers can do. So instead of writing our own, we'll probably use this as an example. So this whole code that we saw here was for the controller, from the sample controller. So there is a package API, which we talked about, how CRDs are generated. And then there is this controller.go, which is the controller code that we ran through. And then there is this whole main.go that brings the whole thing together. So here, now we'll just see how we build those things and run it in the cluster, right? So since it's a Go code, there's a main.go that we can build basically and run it as a binary. So let's do that. So I build this code, and now controllers can be deployed in different ways. You could deploy it in cluster, or you could deploy it outside the cluster and make so it watch the cluster that you're running. So in this case, I'm going to run this controller outside of the Kubernetes cluster. So I don't have to build a container image and push it and use it as a deployment, which could be done, but we'll not do that for now. We'll just directly run it in my local system and point it to a Kubernetes cluster that is running. So now we have a build for a sample controller that runs. So this is how we run. It's just how you run a binary, and we pass it a kubeconfig to the default configuration that holds my Kubernetes cluster information, and I run it. So as soon as I start, you see a lot of things that are happening here. So first thing it does, it sets up event handlers. So this is basically where all your watching for your desired state and current state is handled, right? So if your controller is interested in all the deployments that are there in the system, you start watching for those and register your handlers, and you also register it for custom resources. Then it starts the controller. A controller cannot function until you have events coming in that can trigger your controller, right? So you set up your handlers, you start your controllers, and your controllers then waits for your cache to be synced. Because controllers need access to continuously needs to read these API resources, right? You cannot continuously hit the API server with request to read resources, right? If thousands of controllers start doing that, your API server will probably be busy, responding to each one of those and probably crash at some point. So what we use is a shared informer cache that that is shared between all the controllers that are there. So all the 1,000 controllers instead will watch for a cache, and Kubernetes will make sure that the cache is usually updated with the latest information in a particular period. So that's what these are for. And now we start seeing a bunch of other errors. So we are interested in this v1 alpha 1.4 resource, but the server doesn't have it. All right. So your controller wants to watch this, but it doesn't exist. So we'll have to fix that first. And there'll probably be another error somewhere for deployments. But yeah. So now how do we fix it? It says failed to list v1 alpha 1 foo and the server couldn't find it. This is because we didn't really create a custom resource definition for our object. So we just assumed it was there, but since it's not a default one, it doesn't exist yet. So we'll have to go ahead and create that. So the example file that we looked before is what we need to create now. So what I do here is do a kubectl create or the CRD of that YAML, and it basically creates a custom resource definition for me. And as soon as we do this, we see that the error in this part, it goes away. So the controller now can watch the foo resource successfully, right? Okay, server has registered this new custom resource definition that defines what a foo object is, and your controller can successfully watch. So it no longer throws you any errors here. So what we'll do next is now just creating a custom resource definition is not very helpful. So we create a custom resource to run the controller and make sure it does what it needs to do. So before doing that, let's look into kubectl get deploy. Okay, we are in the Kubernetes. Let's go back to a default namespace. So I switch to a default namespace and I get a deployment. There is no deployment in this namespace yet. And just to be sure, there is also no static pod running in this namespace. So what we're going to do is, okay, let's also look at kubectl get foo. There is no foo resource defined yet. So we will create one. So example foo is this custom resource that we saw here in this example. So this is what we're going to create. So a kind foo, its name will be example foo. The spec says that, okay, give me a deployment whose name is example foo and has a replica of 1. So immediately when we clear this custom resource, we'll see that an event is triggered and the controller sees that you created a foo resource. And the foo resource says that you want a deployment of replica 1, but it doesn't really exist. So now the controller is going to work and make sure that the deployment exists for you. And it generates a bunch of events that is there using the event recorder. So it says an event occurred. There is an object that user created, right? And now I need to basically make sure that the state is reached. So it does a bunch of things. It gives you events about what it is doing, and it eventually says that, okay, everything is done. I have synced the foo resource successfully. So now if we look back at kubectl get foo, there is a custom resource that we just defined. If we look at kubectl get deploy, there is an example foo, which has a replica 1. So there is up to date is 1 and available is 1, which is what we wanted. And if you look at kubectl get pod, you'll start seeing that there is an example foo for this deployment. So you created a resource that said, okay, I want a deployment that is named example foo of replica 1, and your controller did it for you. When your controller created your deployment for you, the deployment controller that is there in Kubernetes got triggered. It saw that, okay, you created a deployment, so let me go ahead and create a pod for you. So there is a series of things that happen, and that eventually leads up to your pod being present. So that is how your controller basically took you to the desired state. So just to test it out, so what happens if I delete this deployment? Just let's look at it. I just deleted this resource. Now I expect my controller to bring it back up because I still want, that is still my desired state. Let's see if it is there. Yeah, so just 10 seconds ago, a new deployment was created with example foo and replica one. So your controller is basically continuously watching for your current state. It is also watching for your desired state, and it is making sure that you go from your current state to your desired state. So let's do something else. Let's edit the foo resources that we had. Let's first get foo. Mhm. So this is the custom resource that defines what I wanted, and it basically says I want deployment name example foo and replica one. Let's just say I want a new name example foo two, and replica will probably be two for now. So I create that in the cluster. The foo sample controller is updated. So what I did was I updated my desired state of the system to change the name of deployment and the replica. So now if I do a get deploy, there is a new deployment example foo2 created with replica 2. So there's up to date 2 and available 2. So whenever I change my desired state, the controller immediately recognizes that and it creates that for me. Now, since this new desired state says that I want example foo2 to be deployed and replica has to be 2, if I go ahead and delete this older deployment example foo, it will probably not come back, right? Because that's not what my desired state says. It just says I want example foo2. It doesn't say anything about that other deployment. So let's see what happens if we delete it. All right, I just deleted it and I get deploy. Controller doesn't bring it back because your desired state doesn't say anything about it. So yeah, that is how a controller works. So yeah, that's an example of a generic Kubernetes controller that just creates a deployment based on your custom resource. You could extend this to do anything. You could extend this for backup restore. You could extend this for disaster recovery. You could extend this for deploying your custom application, a web server, anything that you can think of. And yeah, that's all I had to demo about the sample controller. So what I also like to show is this other community maintained controllers document. This tells you about how you write controllers and what are the guidelines you should generally follow when you're writing controllers. So this is a gem of a resource when you're writing any controller. So it talks about how you use informers, how you use your work queue, and what are the design patterns what you follow, and what are the things you should keep in mind and all that. So, and it also roughly explains the structure that we went through in much more concise way. And then this is the CNC of white paper that talks about everything related to operators and Kubernetes in general. And it also talks about operators in context of outside of Kubernetes in other orchestrated platforms. So lots of good resources there. And that's pretty much what I have for this. I guess we can get into questions and discussions and look into new things that we want to explore.
Great. Thanks a lot, Umanga. It was a great session, a really informative one, and you really delivered good. So let me just open the bridge for questions. Yeah, so I think you should be able to unmute yourself and ask questions. So do you have any questions? Shumnath, Anurag, Kiran, Vichin. Please feel free to ask because just an interactive session and we are all learning. So
This is usually the fun part of the meetup, right? Where you interact with people, you ask questions. Yeah, the session is just something that you get over with and the real discussion starts now. So yeah,
right.
I'd be happy to have any discussions.
Right. Yeah. We have a feedback from Sandeep. It was a great session. Indeed. I do agree to the full extent that it was a really great session. Anurag, any questions from your end? Shumnath? Even if it is related to something on Kubernetes, please feel free to ask. Not really don't want to be on Kubernetes controllers. We can still try to help.
Can we get access to these recorded videos?
Oh, sure. So Pramod, we do have the YouTube channel. I have mentioned that in the Meetup page, but let me share it here itself. You have past events recorded and uploaded to YouTube. Yeah, so you will get access. And slide-wise, I'll talk to Umanga and get those, if that helps.
Thank you.
And Umanga, if you maybe you can share your contact or how to reach out, if it's okay.
Yeah, I didn't really put it into the slides. So how do I do that?
You can maybe put it in the chat, or don't worry, maybe I can bridge that. No worries on that. Yeah, we can add that to slides and maybe while uploading it, we can have no worries.
Sounds good. I guess most easiest way to reach out is the Kubernetes Slack channel where we're actively monitoring it. So just search my name Umanga and you should get it on the Kubernetes Slack. Yeah, feel free to reach out at any point. Happy to help with any questions.
Right, let me stop recording.